Hello and welcome everyone to Physics Sadhana ECET 2025 for all the branches. Here we are discussing about the chapter Heat and Thermodynamics from the physics. The second most important topic in the heat and thermodynamics is where the maximum number of questions are getting appeared, that is ideal gas. Already the lecture 1 and lecture 2 related to the thermodynamic processes has been updated. This is the video lecture 3. Okay, let's get started. PYQ appeared in the 2011 from the ideal gas concept was given mass of a gas at 27 degrees Celsius. Given mass of the gas at 27 degrees Celsius, T1 value is given as 27 in Kelvin. 27 plus 273, that is 300 Kelvin. Is heated in a glass flask at constant pressure. Pressure is remaining constant, so that the volume is doubled. V1 is equals to V, V2 is equals to 2V, then T2 is equals to what? We know when the pressure is constant, then what is the relation between volume and temperature? Directly proportional to each other. So V1 by T1 is equals to V2 divided by T2. V1 is V, V2 is 2V, T1 is 300, T2 is what? VV gets cancelled, cross multiply, T2 is equals to 300 2s, that is 600 Kelvin minus 273, 327 degree Celsius. This is going to become your correct answer. Go through it. Final temperature in Kelvin. Okay, Kelvin value is not given in here. Kelvin value is not given. The value is given in water, degree Celsius. Go through it. Moving on to the next question. Second question. At a constant temperature, the volume of the given mass of a gas is increased by 10%. Find the change in pressure. Constant temperature, temperature is constant, PV by T, temperature constant, so P1 V1 is equals to P2 V2. Asked the question is, the volume of a given mass of a gas is increased by 10%. Volume increase, percentage increase in volume, that is equals to V2 minus V1 divided by V1 into 100. This value is given as how much? Increased by 10%. This is equals to 10. Okay. Or you can write like this also. If V1 is equals to, you are taking the value as 100, V2 is equals to what? 110. Volume of the given mass of gas is increased by 10%. Find the percentage change in pressure. Question is percentage increase in pressure. That is equals to P2 minus P1 divided by P1 into 100. That can be written as P2 by P1 minus 1 into 100, where P2 by P1 is equals to V1 divided by V2. So this is going to become your answer, V1 by V2 minus 1 into 100, where V1 is how much? 100, V2 is how much? 110 minus 1 into 100. So this is going to become 100 minus 110 divided by 110 into 100. 100 minus 110 is minus 10. Minus 10 divided by 110 into 100. 0, 0 gets cancelled. 1 divided by 11, that is 100 divided by 11 he is asking. 100 divided by 11. So we know that this value is going to become 100, 11 ones, 11 nines. 11 nines is how much? 99. Point. Okay, if 100 is divided by 11, so 11 nines we can write, 11 nines is 99. So 1 is remaining. You're going to keep a point here, so 0 0 again. Okay, 0 0 again. So again 11 nines so this will be 99 again. So this value is minus 9%. Okay, you can write like this, minus 9.09 in terms of percentage. This value you want to write, that's 9.99. 9.9. Okay, so if it is going to be decreased by, find the percentage change in pressure. Percentage is decreased by 9%, 9.09. So correct answer is going to become how much? That is 100 minus 9, that should be 90.9. Right? 90.9 should be your correct answer. Go through it once. Go through it. Because overall we can think like this, that if this value is 100, the answer would be what? 10%, that is in minus sign. Reduced by 10%, your answer would be what? 90. But it is not equal to 100, it is more than 100. If it is more than 100, the value should be lesser than 90. Okay, my mistake. So we can write like this over here itself. What is this value now? This is minus 10 divided by 110 into 100. Okay. P2 by P1 minus 1, V1 by V2 minus 1, 100 minus 110 by 110 into 100. So this is minus 10 by 100. If this is equals to 100, what is the answer? Minus 10%. That would be 90, would be the correct answer. But we can say the denominator is increasing. Denominator increasing, overall value will be decreasing. So the value should be lesser than what? Lesser than the 10%. That's what we are trying to say here. Less than 10%. If it is lesser than 10, that means the answer should be what? Greater than 90. Like this. So this value would be what? 90.9 in terms of percentage. Go through it once. Chalo. Pause the video and note it down. Let's move on to the next question now. The next question given over the board is, at constant temperature, the volume of given mass of a gas is increased by 10%. Volume of gas is increased by, if V1 is equals to 100, V2 is equals to 110. Find the percentage change in pressure. Percentage, if it is increasing, so pressure decreases. Percentage decrease in pressure. Percentage decrease in pressure is equals to P1 minus P2 divided by P1 into 100. You can write like this, 1 minus P2 divided by P1 into 100. P2 by P1 in terms of volume will be V1 by V2 into 100. So this is going to become V2 minus V1 divided by V2 into 100. So what is the V2? 110. What is the V1? 100. What is the V2? V2 is 110 into 100 it is. So this is going to become 10 by 110 into 100. Okay. So what we can write here is, let's say this value is going to become in percentage. So leave it this one. This is 1 divided by 11. 1 divided by 11. If it is 1 by 10, that is 0.1. It is greater than 10 in the denominator, so the value will be lesser than 0.1. So approximately this value is 0.909 into 100. Okay, that is not 0.09 because not 0.1, 0.09. So this value is what? 9.09 in terms of what? Percentage. So if the value is going to be decreasing by 9%, so we can assume that pressure P1 is equals to 100. So P2 is going to be reduced by how much percentage? 9.09%. So the P2 value is going to become what? 90.9. Okay, 90.9. It's not in percentage, but 90.9 is going to become your correct answer. Okay, go through it. Percentage should be 9%. Moving on to the next question. If n represents Avogadro's number, then the number of molecules in 6 grams. We know the formula. Number of moles is equals to number of molecules divided by Avogadro number, that is equals to mass divided by molecular weight. Number of molecules is our question. So number of molecules divided by Avogadro number is equals to, what is the mass given? 6 gram. What is the molecular weight of hydrogen? Hydrogen molecular weight is what? 2. 2 1 the 2, 3 sa. 3 into n. 3 into n is what? 3n. So number of molecules is equals to, what is the answer? Number of molecules is equals to 3n is your final answer. Formula you have to memorize. Number of moles is equals to molecules by Avogadro number, mass by molecular weight. Mass is given, molecular weight we know, mass by molecular weight is 3. 6 by 2. 6 by 2 is 3. 3 into denominator n, 3n is your final answer for number of molecules. Appeared in the ECET 2012. Next question. The next question given over the board is from the ECET 2024. A sample of an ideal gas has volume V, pressure P, temperature T. The mass of each molecule of gas is m. mass of each molecule, then the density is, we know density is equals to mass divided by volume, where mass of each molecule is m, so total mass will be mass into number of molecules divided by volume. We know the number of molecules formula, just now we have written. Number of molecules is, what is the formula? Number of moles into Avogadro number. So we can write NN in the place of number of molecules, we can write N into N divided by V, where small n is number of moles, capital N is Avogadro's number. Okay. So this N by V focus now. What is the formula for N by V? PV is equals to N into RU into T. N by V is equals to P by RUT. So in the place of N by V, you can write P divided by RUT. Send this Avogadro number to the denominator. This will become MP divided by RU by N T. Now you need to memorize that Boltzmann constant. Boltzmann constant K is equals to universal gas constant divided by Avogadro's number. So here RU by N, universal gas constant by Avogadro number, is Boltzmann constant, that is K. Final answer is what? MP divided by KT. This is the formula for density now. Density is mass by volume. Each molecule is m, so total mass will be m into number of molecules. Number of molecules formula from the previous question. Number of molecules is equals to number of moles into Avogadro number, n by n, n into n. N by V is P by RUT, and finally RU by N is called as K, that is Boltzmann constant. Revise, repeat, definitely you will understand once you practice it thoroughly. Liter of gas is at 27 degrees Celsius. T1 is equals to 27 plus 273, that is 300 Kelvin. Then the temperature required to heat to make its volume double. V1 is equals to V, V2 is equals to 2V, then T2 is equals to what? What is the formula? We know that liter of gas is 27, temperature required to heat to make its volume double. Assuming that pressure is constant. If pressure is kept constant, then volume is directly proportional to temperature. Okay. If volume increases twice, temperature also gonna become twice. That is V1 divided by V2 is equals to T1 divided by T2. If V1 by V2, V1 is V, V2 is what? 2V, then T1 is equals to T, T2 is equals to what? VV gets cancelled, T2 is 2T. That is 2 times of 300. That is 600 Kelvin. That is 327 degrees Celsius. 327 degrees Celsius is the final answer. See, this is a repeated question. Moving on to the question number 6. If the pressure of gas is increased 4 times, then its absolute temperature is reduced to half. Pressure of the gas is increased by 4 times. Its absolute temperature is reduced to half. Its initial value, ratio of initial to final volume, V1 by V2 is equals to what? We know that P1 V1 by T1 is equals to P2 V2 divided by T2. Asked question is V1 by V2 is equals to P2 by T2 into T1 by P1. P2 is equals to 4P divided by P. Initial temperature T, final temperature T by 2. T, T, P, P cancel, 4 2s are 8. So what is the answer going to become? 8 is to 1. V1 by V2 is equals to 8 is to 1. This is your final answer. Ideal gas equation, P1 V1 by T1 equal to P2 V2 by T2. Moving on to the question number 7. Question given is the pressure density adiabatically. Okay, this is a relation, already this is a repeated question now. P dash divided by P is equals to D dash divided by D whole to the power of gamma. 32 to the power of 7 by 5. 2 to the power of 5 whole to the power of 7 by 5. 5 gets cancelled, 2 to the power of 7. 2 power 7 is how much? 128. Have to know that in the adiabatic process, P2 divided by P1 is equals to V1 divided by V2 power gamma or D2 divided by D1 to the power of gamma. This is the relation. Ideal gas equation for adiabatic process. Moving on to the question number 8. The pressure remains constant. If pressure is remaining constant, PV divided by T, pressure is kept constant, and volume and temperature both are directly proportional to each other. Volume of the gas will increase with increase in temperature. Go through it. Very simple. Moving on to the question number 9. A vessel contains a gas at a temperature of 27 degrees Celsius. T1 is equals to 27 plus 273, that is 300 Kelvin. Pressure of 20 atmosphere, pressure is equals to 20. If one half of the gas is released, let's say N1 is equals to N, N2 is equals to N by 2, number of moles becomes half, and the temperature of the remaining gas is raised by 50 degrees Celsius, and if T2 is equals to 27 plus 50 degrees, that is 77, 77 plus 273, 273 plus 77, what is this going to become? This is 0, 7, 7, 14, this is 15, this is 350. So final temperature is 350 Kelvin. Okay. Now, the new pressure P2 is equals to what? We know the formula. PV is equals to nRUT. Assuming here the vessel is having what? Constant volume. So the formula gonna become what? P by NT. P1 by NT1 is equals to P2 by N2 T2. Asked question is P2. Make a formula for P2 now. P2 is equals to P1 into N2 T2 divided by N1 T1. P2 is equals to P1 is 20, N2 by N1, N2 divided by N1. N2 is how much? N by 2 divided by what? N1 is N, and then gets cancelled. So what is this value now? 1 by 2. T2 by T1, that is 350 divided by 300. 350 divided by 300. 2 ones are, 2 tens are, 0 0 gets cancelled. Okay. 5 sevens are, 5 6 are, 70 divided by 6. 6 ones are 6, remaining is 1. Again 6 ones are 6, remaining is 4. 4, 46 6 are, that is 6. Again 11.66. So what is the final answer going to become? 11.67 atmosphere. Go through it. Moving on to the question number 10. The question number 10 given over the board is two cylinders of volume 20 cc and 30 cc. V1 is equals to 20, V2 is equals to 30. Have gases at a pressure of P1 is equals to 40. Let's say P2 is equals to 50. And at the same temperature, T1 is equals to T, T2 is also equals to T. If they are connected by a narrow pipe, the pressure in centimeter becomes what? That means total number of the moles is equals to N1 plus N2. Number of moles formula PV divided by RUT is equals to P1 V1 divided by RUT1 plus P2 V2 divided by RUT2. Assuming that the temperature is constant, so temperature universal gas constant gets cancelled. Okay, final pressure is what he is asking. Final pressure. Final volume when both are going to be connected to each other, that is 30 plus 20. 30 plus 20 will become what? 50. Initial pressure is how much? 40. Initial volume is 20. Initial pressure 50. Final pressure 30. Okay, two connected. So 4 2s are 8. 5 3s are 15. 15 plus 8, what is this value going to become? 23. 23 double 0. Here we are having 50, so 50 denominator. Final pressure 0 0 gets cancelled. 5 ones are 5, 4s are 5 4s are 20, remaining is 3, 5 6s are 30. So what is the final answer now? 46. This is the 46 centimeter of HG. Go through it. Chalo, pause the video, note it down. Moving on to the next question. Next question is question number 10. Ideal gas has a volume V, pressure P, temperature T, mass of each molecule of the gas is M, density of the gases. This is a repeated question. Already we have seen density question here. That is, density is equals to, yes, this is the formula. Density is equals to mass by volume, and finally we got the answer as MP by KT. MP by KT. So here, this is going to become your correct answer. Density formula MP divided by KT, where K is called as Boltzmann constant. Repeated question. Go through it once. Now let's move on to some important expected questions for the ECET examination. Question number 1. The general gas equation PV equals to RT was improvised by van der Waals equation. First of all, let me give you the van der Waals equation. Van der Waals equation is P plus A by V square into V minus B is equals to RT, where this A and B are representing force of attraction between the molecules. Yeah, force of attraction. Between molecules, or molecular attraction we can say, and this B is talking about volume occupied by gas. This is A. What is the asked question? This A by V square is talking about what? This A by V square is talking about the molecular attraction. Expected question in the examination. Make sure you note this one. Moving on to the next question. Let me tell you one more important point here. What happens when A and B are assumed to be 0 for ideal gas? For ideal gas, A is equals to 0, B is equals to 0. That means this equation will be reduced down to what? PV is equals to RT. And this equation is called as which equation? Ideal gas equation. Okay? Van der Waals and ideal gas. Moving on to the question number 2 in the important questions. The question number 2 is talking about, for a gram molecule of a gas, the value of the gas constant with the constant R in the equation. Usually PV is equals to, this is nRT. N is equals to, suppose this is 1. R value in terms, standard value is 8.314 joule per mole Kelvin. Mole is unity, so 8.314 joule per Kelvin. 1 calorie is equals to 4.2 joules. I want to convert this in terms of calories, so divided by 4.2 now. Divided by 4.2. Approximately this will be what? Around 2 times. Approximately. This is 1.97 something. Approximately it is 2 calories per Kelvin. Remember both the values. 8.314 or 2 calories. So what is the correct answer for this question going to become? 2 calories per Kelvin. Okay. Moving on to the next question, ideal gas. You should know about, this is called as saturation dome. Saturation dome. Saturation curve. Anything above it is called as what? Gas. Anything below it is vapor. Vapor can be liquefied. Vapor can be liquefied. Whereas gas cannot be liquefied. Gas cannot be liquefied until it is inside the saturation curve. So what is the ideal gas now? Ideal gas is something which cannot be liquefied. Which cannot be liquefied. That is the difference between the gas and a vapor. Moving on to the next question. And here remember one more important point. This is the point where the latent heat is going to become 0. Latent heat. This is the latent heat actually. These horizontal lines. These horizontal lines are reducing to what? 0. Latent heat is equals to 0. And this point is called as critical point. Critical point. For water, critical pressure and critical temperature. What is the critical? What is the critical temperature? Critical pressure is around 220 bar and temperature is around 373 degree Celsius. standard values for water. Question number 3, important question. The unit of the universal gas constant, just we discussed about the universal gas constant value, 8.314 joule per mole Kelvin. So what is the unit now? Joule per mole Kelvin. Joule per mole Kelvin. K is Kelvin here. Okay? Remember. Moving on to the question number 4. A jar, that's question number 5. A jar A is filled with a gas characterized by pressure is P, volume is V, temperature is T. Another jar of pressure 2P, volume V by 4, temperature 2T. The symbols are the usual, meaning the ratio of the number of the molecules in jar A to the jar B. We know the formula PV is equals to N into RU into T. Let's say universal gas constant is a constant value, so N is equals to PV divided by T. So Na divided by Nb, ratio of the number of moles in the jar A to that of the jar B. Na is first one P V by T divided by second pressure is 2P, second volume is V by 4, temperature is 2T. PVT gets cancelled. This 2 gets cancelled. 1 by 4 going to the numerator, it will become what? 4. So what is the final answer going to become? 4:1. Go through it. So this is all about the part 1 of ideal gas, where we have seen few PYQs, and based on the PYQs I have given you some important questions for practice too. Okay. Make sure you subscribe the channel and press the bell icon to be notified. Every day in the physics sadhana we are going to be updating some videos related to physics, PYQs, and based on the analysis of the PYQs we'll be giving you some important questions to practice. Okay. Make sure guys you prepare well for the ECET examination. If you follow every single day 7 PM sharp, these videos definitely is going to be enhancing and boosting your physics knowledge up to the mark of ECET 2025. Thank you very much. With such more content and with one more video, I'll be seeing you tomorrow. Keep learning with SAIMEDHA.in.